Hi friends, today I am going to explain the second unit of computer graphics. In this unit, it will explain all the different types of algorithms like line drawing algorithms, circle drawing algorithms, ellipse algorithms and so on. And initial concepts are explained the line drawing algorithms. We know that the line equation in the normal mathematical y equals to mx plus c. So based on this equation, we can derive so many coordinates, and here the line drawing algorithms is take the coordinates to draw a line on the screen. So basically, we need to understand one of the concept before we go through these algorithms. So what the thing is, the computer cannot take the lines or the images directly to display onto the screen. A normal input it takes through the keyboard or any other input devices that we can observe in the first unit. Some of the data is taken through the keyboard or any other device to display it onto the screen. But coming to this line or the circle or the ellipse and any other images should not take directly, and which is displayed onto the screen. So now what the possibility is through the algorithms only, so we can draw the line or the any other images we should be operated. Now we go through this particular concept of line drawing algorithm. What the line is, a line should be taken in between the coordinates. A coordinates in the sense a starting coordinate and the ending coordinate. Not only that, the image of a pixel can be taken in between the starting and ending coordinates. That means the intermediation coordinates are also defined through these particular algorithms. Now there are different types of line drawing algorithms, and popular algorithms are the digital differential analyzer, Dda line drawing algorithm, and Bressenham's line drawing algorithm, and the third one is the midpoint drawing algorithm. Now this session I am going to explain the line drawing algorithm related to the Dda. So now coming to this digital differential analyzer algorithm, Dda algorithm, whatever the algorithm is related to the line, it will be focused on only the two important points. One is we should take the any criteria takes the starting and ending coordinates. So without these coordinates we can't start to create any line or any image. So here we take the starting and ending coordinates, and second important factor is we need to find the intermediation devices in between the starting and ending coordinates. So here how we will find the intermediation devices, this is the major part. Now we are going to discuss in detail of this Dda algorithm. Now the procedure is the given x coordinate and the y coordinate, that is the starting of x0 and y0, and the ending coordinates are y0, xn and yn. So based on these two coordinates we will find some of the intermediation device with the given procedure explained by the Dda algorithm. So here we need to understand the starting coordinates x0 and y0. So that is the starting point of the line, and the ending point of the line is xn and yn. But we need to find the intermediation devices or intermediation coordinates between the xn yn and xn x0 and y0 and xn yn. Now coming to this algorithm, this algorithm mainly focus on to find some of the factors like delta x, delta y and m value, where delta x is the difference values of the x coordinates, and the delta y is the differential values of the y coordinate. It is also denoted as an dx and dy also. So we know that the differential equations we can write the dx by dy like that. So the dx is nothing but the differential values of the x coordinates, and dy is the differential values of the y coordinates. Like here the Dda algorithm explained in this way the delta x and delta y. So and m is the slope value Here some of the notations are given where delta x equals to xn minus x naught and delta y equals to y naught yn minus y naught, and the slope value m equals to delta y by delta x. So initially we can find these three values. So to finding the coordinates or the intermediation coordinates in between the starting and ending coordinates. Now coming to this, the second step of this algorithm is, now this is the major point in this algorithm. So because we doesn't know how many intermediation points are defined in between the starting and the ending point. This is the major issue. So basically they are giving the starting and the ending coordinates, okay fine, but without intermediation coordinates we can't take the a line in between the coordinates. So how many coordinates are defined in between the starting and the ending point? So this Dda algorithm will explain one of the concept. What the concept is, if absolute value of delta x is greater than absolute of delta y, so the absolute of delta x is greater than absolute of delta y, then the number of steps in the sense the iterations in the sense the number of coordinates. So the number of coordinates in between the x coordinate and the starting coordinate and the y coordinate are nothing but the absolute of delta x. So when it is possible is, if absolute of delta x is greater than absolute of delta y, then the steps equals to delta x, absolute of delta x. Else in the sense, if the condition is not true, then the control goes to the else part. In this else part, the number of steps equals to absolute of delta y. So based on this condition only, we will find the number of coordinates in between the starting and ending points. Now coming to the third procedure, the third step of this algorithm is, suppose the current point is xp and yp, and the next point is xp plus 1 and yp plus 1. Here you can observe the starting points are the xp and yp sub, for example. So in the next parameter, that means we need to find the next parameter for drawing the move of the line from the starting point to the next point, next coordinate. So how we can find the next coordinate in the sense, that is with the help of the slope value. Based on the slope value, here the Dda algorithm explain three conditions. So this is the major point in this algorithm. So first what we do is, so initially, so we take the starting and ending coordinates, so that is x0 y0 and x and yn, and we can find the delta x value, that is the differential values of the x value, and the delta y, the differential of the y value, and the slope value m equals to delta y by delta x. And how many coordinates we will find in between the starting and ending point is nothing but, here based on the absolute of delta x value is greater than absolute of delta y, then the number of steps equals to delta x, or else part we go to the next choice, next part, if the condition is not true, then we go to the number of steps equals to delta y. So now coming to the how we will find the next coordinate, that is the next step. So we will find the next coordinate with based on the a given condition of the m value. M is the slope value. Here the Dda algorithm, the digital differential analyzer algorithm, explain the three conditions based on the m value. If first case, what the first case is, if m value is less than 1, m value is less than 1, so we will find the next coordinate xn plus xk plus 1 equals to the round of 1 plus xk. Here you can observe xk plus 1 or xp plus 1, that is the general notation. Here we can use the next value in the sense, sometimes we can use the xn or the xp or the xk. So these are the general notation. That means the plus 1 in the sense the next coordinate. So that you can understand in this particular case one. So if m value is less than 1, so we will find the next value. So with the help of xp plus 1 equals to the round of 1 plus xp. So yp plus 1 equals to round of m plus yp. So this is the first condition. If m value is less than 1, then the next coordinates x plus xk xp plus 1 equals to round of 1 plus xp. What is the meaning of this round off? Round off in the sense, if the value is 0.5 is the value. Suppose for example, what is the value of round of 0.5 is nothing but the 1. So if the value is 0.4, what is the round value of 0.4 is nothing but the 0, because if it is less than 5, 0.5 or anything less than the 5 notation, then it comes to the previous current value. If it is greater than 5, we go to the next value. Here the round off, in the sense the round of 1 plus xp. If the value is suppose 5.5, what is the round of 5.5 is nothing but the 6 value. So that is the first case. And coming to the second case, in the second case, if m value equals to 1, if the slope value equals to 1, so we will find the next coordinate with the help of xp plus 1 equals to round of 1 plus xp. This is the similar of the above. And the yp plus 1 equals to round of 1 plus xp. Here is the change the y coordinate. So the yp plus 1 equals to round of 1 plus yp. So this is for the case 2. And the third case is the if slope value m value is greater than 1. So what we do is that it will find the next parameter xp plus 1 equals to round of 1 by m plus xp. 1 by m plus xp, and then yp plus 1 equals to round of 1 plus yp. So these all are the conditions given by this algorithm only. So these are not the values are related to the we are not finding any notations of this DDA, because of the DDA procedure is, so here the three cases are defined. The case 1 is depends on the m value. If m is less than 1, we will take the next coordinate in the different manner. If the case 2, if m equals to 1, so we will take the next notations of the to find the next coordinates. And the third one is case 3, that is if m is greater than 1, then we can find the next coordinate is like this. So when we find the m value, then only we can decide it. So the next coordinate. So this will be continue. So this will be continue until the last point is reached. This is the important one. So when we will continue this particular finding the next coordinates is nothing but up to the last coordinate, last ending point is there. So we already discussed in the initial one, the starting coordinates are x0, y0, the ending coordinates are x and yn. So in what way this particular procedure will continue, so how many iterations we will continue is nothing but here it can be reached to the last point. So this is one. So and coming to this particular practical example of this DDA algorithm, now we can observe the 4 important steps. So the first one is, so we are taking the initial and ending coordinates, that is the first one. Next one, we will find the delta x value, where delta x is the differential values of the x, delta y value, the differential values of y, and m value, that is the slope value, m equals to delta y by delta x. And coming to the next step, so how many coordinates we will be taken in between the starting and ending point is nothing but based on the absolute value of the x. If the absolute value of x is greater than absolute of y, then we can take the number of steps or the iterations equals to absolute of delta x and go to the else part in the sense if the condition is not true, then we go to the next part, the number of steps equals to absolute of delta y. And the next one, so we will continue this process to finding the next coordinate with based on the slope value. If the slope value m is less than 1, it takes the one condition. If m equals to 1, it takes the one condition. If m is greater than 1, it takes the one more condition. Now we are going to take the last step is nothing but, so we will continue this particular process until the ending point is reached. Now coming to see the practical example. Suppose we takes the starting point is 5, 6 and the ending coordinates are 8, 12. We will find the coordinates like delta x equals to xn minus x0, which equals to 8 minus 5, 3. Delta y equals to similarly y0 minus yn minus y0, which equals to 12 minus 6, that is 6 value. And m equals to the slope value delta y by delta x, that is 6 by 3 equals to 2. Now coming to the slope value, m is greater than 0. So m is greater than 0. is in the sense you can observe here the three conditions. The three conditions are taken. So before that, how many sequence of steps, how many sequence of intermediation devices to find the between the starting and the ending coordinate is nothing but, so we can find the absolute delta x is less than the delta y. Here what is the delta x value? 3. Delta y value is 6. So the greater value is the delta 6. So we go to the initial part of the procedure of the algorithm. If absolute of delta x is greater than the absolute of delta y, then the number of steps equals to delta x. Otherwise the number of steps equals to delta y. So here the delta y value is the greater value. So the total number of iterations in between the including the starting and ending point is the delta y, that equals to 6. The next one here, the slope value m already we can calculate it here. So we can observe what is the slope value equals to, then m equals to, so we can take the delta y by delta x. So what is the delta y? Delta y is the 6 value, delta x value is the 3. So then m equals to 2 value. So m equals to 2 value in the sense, so we can observe m is greater than 1. So m is greater than 1 in the sense we go to the third case. Here you can observe the third case. Already we discussed this third case. If m is greater than 1, because slope value m equals to 2 in the sense, we go to the next that is the greater value. So then what the coordinates? We will find the coordinates in between the starting point and the next point, that is xp plus 1 equals to round off 1 by m plus xp, and yp plus 1 equals to round off 1 plus yp. So this is the condition we will find. Now you can take, this is the coordinates. So what the coordinates, and xp yp is the starting coordinates. The given problem, the starting coordinates are the 5 6. Now we will take the next value. So if x is greater than 1, then we go to the third case. In the third case, you can observe the round off xk plus 1 equals to xp plus 1 equals to the round of 1 by m. What is the condition here? You can observe. So this is the condition, xp plus 1 equals to round off 1 by m plus xp. 1 by m in the sense m value is 2. So 1 by 2 is 0.5. 0.5 plus xp value is the 5. So that means 5.5. Here you can observe the 5.5. So the 5.5 and the next coordinate, y coordinate equals to, so yk plus 1. Yk plus 1 in the sense that is 6. 6 plus 1 equals to 7. So the next coordinates of 5.5 and 7. But here we can apply the round off. The round of 5.5 becomes to the 6. The round of 7 becomes to the 7. So the coordinates of the round off coordinates of xp plus 1 yp plus 1 is 6 comma 7. In the next one, again you can see what is the initial m is greater than 0, no? Then we can, m is greater than 1, we can continue this process until the last coordinate is reached. What the last coordinate? Given 8 comma 12. So you can observe the derived coordinates are 6 comma 7. Again you can take the 6. Again you can apply the same method. The next coordinates are the 6 8. So again you can take the 6 and 1 by m equals to 0.5. You can add the 6 plus 0.5, 6.5 in the next coordinate. Again the 0.5 is added the next coordinate 7. 7 plus 0.5, 7.5. 7.5 plus 0.5, that is 8. So you can take the x coordinates is added the plus 0.5 plus 0.5 every time, and y coordinates is gradually added the 1 1 1, because in the given equation if m is greater than 1, then xk plus 1 equals to round off 1 by m plus xk, and yk plus 1 equals to round off 1 plus yk. So that's why here every time the incremented by 0.5 for the x coordinate, and every time 1 is incremented for the y coordinate. Now we can consider the last coordinates are the 8 12. So what this procedure is, you have to start at the initial coordinates 5 6, and we have to reach up to the ending coordinates, that is given 8 12. See here the number of coordinates are 1 2 3 4 5 6. Already we discussed the number of coordinates are, total number of coordinates are 6. including the starting and the ending point. How we will find that? If absolute of delta x is greater than absolute of delta y, then number of steps equals to absolute of delta x, else what absolute of delta y. So the delta y becomes to the 6, the number of coordinates are 6. Here also it can be reached the destination coordinate, that is 8 and 12. Now you can see the graphical representation. So this is the important one in the line drawing algorithm. For any line drawing algorithm, we take the x coordinates are in the x axis and the y coordinates are in the y axis, and you can take the points. The first point is the 5 6 in the starting point, that you can observe here clearly. So this is the starting point and this is the ending point. Now we will find the intermediation devices. This is the intermediation coordinate, that is 1, this is 2, this is 3 and this is 4. The 4 coordinates we will find, including the starting and the ending coordinate. The total coordinates are the 6 coordinates we will find. So this is the DDA algorithm, digital differential analyzer algorithm. This algorithm is a very fundamental algorithm to draw the line on the screen. So that means in a computer we can draw the line like this only. So using this procedure, using this standard, one of the standard, we will prepare a procedure. After that we will take one example and we have to take the starting and ending coordinates and we will find the in between the coordinates, and finally we can draw the line. But all these values should be depends on the slope value m. So the slope value m equals to delta y by the variance values of y coordinate divided by the differential values of the x coordinate. Differential values of the y coordinate yn minus y0, differential of the x coordinate xn minus x0. So this finally depends on the m value. Slope value is taken the 3 different cases. If m is less than 1, if m equals to 1 and m is greater than 1. So based on this condition only this algorithm should follow. So I will explain in the next video. I will continue the line drawing algorithm, that is precedence line drawing algorithm.